All right, what is up, everyone? Welcome to week 69 of Chill Kernel Hacking for Fun. I am, give me a couple moments just to collect myself. I'm coming in a little bit late today, and I need to post on Discord, etc. that I'm doing this. Yeah. So today is going to be kind of an interesting stream. There we go. I'll also get test 0 in the chat. Yeah, today's going to be kind of an interesting one because we're beginning a new era for my streams. Because last week I finished the MIT course, which was a pretty big milestone. And now we're just kind of free to do whatever we want in the world of operating systems and low-level programming. And for me, what that means is I'm going to be working on just my personal bucket list of things that I find interesting. And we're going to start out with the boot process. Again, we're going to kind of revisit this topic, which we haven't looked at the boot process in a bit. But that's personally something that's kind of interesting to me to get back into. Sorry, I'm still putting out all the relevant stuff. I'm making a tweet right now. What are we saying? Last week we finished the MIT course, so we'll begin with side quests, starting with porting the OS to use grub multiboot instead of a custom VR bootloader. Okay, publish tweet. All right, your tweet has been published. Cool. Welcome to anyone joining the stream. All right, I posted on Discord, I posted on Twitter, and we will soon be ready to dive into things. But yeah, I hope everyone's having a nice Sunday right now. Anything else I need to do? Just clean up some of my tabs, maybe. But yeah, so we're going to be looking at some boot process stuff today, and we're going to try to port the operating system to use grub. Currently, the OS uses a custom bootloader. It's super small, extremely minimal, and it's just totally custom. And I'd like to try using something a bit more professional. Also get the timeout thing running. Yeah, I'd like to move to something a bit more professional. And for me, that means grub. Grub is more like one of these industrial strength bootloaders. But people also use it for hobby operating system development, and I've always been kind of curious about it. So we're gonna try using grub. I have a little bit of work actually that I've already started with, so I can show you that, but it's not working. And what I want to do is try to get it working, obviously. And so what we're gonna hopefully see today is going through the process of debugging what this even looks like, debugging boot failures of the operating system, and making small steps until we can port the OS to use grub. I'm going to open my Miro board. So here's a couple of screenshots of my attempts and the latest state of my progress, which was these error messages. And so we're going to be mucking a lot with the really essential core infrastructure of the kernel. In particular, we're going to need to get into, I think, the linker script. Yes. So, yeah. All right. Anything else to mention? I don't think so. So let's just, yeah, let's get into it. So here's what I have so far. I have an extremely basic setup where I've added a grub config file. And then I've added this small build target or build command to my build system for generating the grub image. And what it does is it just basically creates a bit of a directory structure. Ismail, what is up, my friend? Good to see you. Let's go. Yeah, today we are getting into some grub stuff. We're gonna actually hopefully try to use a professional bootloader instead of the very amateur bootloader that the kernel has been using this entire time. So here's how you use grub. I'm not really that familiar with it, actually. Yo, we got Lizard in the house also. Crazy. We got a stacked stream today. Good to see you. See everybody. Yeah, I'm just getting started with this topic. So I'll be away next week. So I have a pre-recorded stream for next week, and I was working on that like earlier today. And so we have a bit of like very basic starting work that I've done. But it's kind of a new topic, and the new topic is just using grub. And here's how you use grub. Like I actually don't have a lot of experience with grub because I don't have a lot of experience like installing Linux onto computers and stuff, actually. Embedded bootloaders, yes. On the other hand, I actually do have quite a bit of experience with embedded bootloaders such as U-boot. Mostly from my work on Ableton Move, which uses U-boot. And I'm curious if any of that knowledge will transfer over. Maybe it will. Maybe it will. But for starters, here is a bit of a basic grub setup that I got from the internet and from ChatGPT. We basically just create a directory structure, and you just copy things into this particular structure, and the structure looks something like this. It's very simple. You just have a boot directory, and inside the boot directory you have the kernel, which is an elf file. It's the normal elf file that gets produced by the build system. Then you have a grub folder and you have a grub config. So Vinay, thank you for the compliment. Thank you for the support. Thanks for being here. Yes, so, MCU boot and a proprietary one, interesting. Never heard of MCU boot. Yeah, let's see, so that's basically an ultra simple way to get started with a grub. you create this directory structure, and then you can magically run this this command called grub makerescue, which I feel like it has to take the spot of one of the worst named tools ever. But you pass it your directory, and then it bundles this up into something, some kind of file. I think it's like some kind of strange disk format, actually, either for floppies or something weird like that. I don't really know do they call it initialization code rescue? I think the intention is like you use this to make like a rescue disk or something like this. I don't actually know. Maybe there's actually a better tool or something like this, but this makerescue thing is used in every single tutorial and ChatGPT. I think it's an extremely standard tool. And so for some reason it's called makerescue. And it bundles up your folder that you made into a way that grub knows how to deal with. I'm actually going to take some notes while I just have this in mind. So things I want to learn about: how to make grub print/use the serial console instead of only VGA. That was something pretty inconvenient that I ran into. Secondly, how to use the grub shell. I'm also interested in that. All right. So this is like, I don't have very much here. One thing I also do want to pull up is I have like a million of these tabs open for like how to use grub. We don't need this tab anymore. This MIT class, goodbye. What I realized is I made a big mistake with starting out this work. I actually should have gone for the grub documentation. And grub manual PDF even. That would be so cool if I could get a PDF. Looks about right. I'm going to go ahead and just yeah, I'm just going to wget this into my docs folder. Docs? Oh, dang. Docs. Well, it's kind of slow. But anyway, I actually think the documentation is a very underlooked starting point for a lot of these things. It's so easy to just default to Googling or ChatGPT these days, but actually the documentation is obviously a good supplement to this. And I was actually reading it in between my earlier work today and right now, and what I realized is that first of all, it's actually pretty good documentation. Second of all, they give you pretty critical information about the core concepts here. And actually, no, I'm actually realizing I made a mistake. So one of the most important things that they do is they point you to this thing called the multiboot specification, which is some kind of specification around booting, and grub is simply an implementation of this. And so really that's what we need to learn about, is the multi-boot specification. If we can become multi-boot compliant, then we should have no problem using grub. And I was in the HTML version of this. There's like a link. Wow, did this thing get frozen or something? Like, why did that downloads just stop? Okay, that's unfortunate. I'm just gonna drag this off screen while I save the document. Grub docs. And then also, yeah, what we need is really, so I mean, here's the HTML manual. What we actually need is the multi-boot specification. I think people get kind of nervous around reading raw specifications, but I was reading through this and I actually think that's huge. So we go to this motivation section. So we learn about the history of grub, something about multi-boot. We go, and then here we go. We got the multi-boot specification right here. This is super important, and I'll just jump straight to the end. What they actually do here is they give you a working reference operating system. Because when they made the multi-boot specification, no one was using it, so they're trying to make it easy for people to make their kernels multi-boot compliant. And a good way to do this is to provide a reference implementation of how to do that. And so I think we'll be using this. They give you a reference operating system. Yeah, it's not like obviously it's not a full operating system, but they give you all the important parts. They give you a multi-boot header file, which I suspect might be useful. And then they also give you a basic boot assembly file, and also a basic kernel.c, just to get things going. So I think this will be pretty helpful, because I actually think it'll be a little bit of work to do this port. With the current implementation of my operating system with JOS, there are a lot of assumptions around how things work. For example, the kernel is designed to get loaded into high memory at a specific address. I don't know. There's a lot of assumptions around that, and I think multi-boot will change some of these. So I think it will be a decent amount of porting work. So it's good to have this. I want to get the multi-boot PDF if we can find that. That would be super cool. Dang, multi-boot 2. Shit. Wait, do we want to use multi-boot 1 or multi-boot 2? I have some vague recollection that is multi-boot v1 obsolete? I know grub v1 is obsolete. Okay, it's simpler. Interesting. So, okay, and then, so there's like grub legacy and grub 2. Grub legacy is super obsolete. You don't want to be using grub legacy. It was last like updated in 2005 or something like that. But apparently multi-boot 1 is still supported. So I think we're going to go with multi-boot 1 for right now. Is this the thing I'm looking for? Examples? Yes, I think it is. Doc. All right, multi-boot doc. Open with system viewer. We got skim, our hardcore PDF viewer open. We got the grub PDF. We got all our PDFs. So Bacon, we are working on porting the operating system to use grub as the bootloader today. That's the goal. Oh man, we got Digitalized in the house also. What's up, Digitalized? Good to see you. It's a party today. If I understand correctly, we use slot 1 and slot 2 for updates on embedded systems because there's no file system, but a proper OS can modify its file system. I mean, embedded systems can have file systems too. I mean, it depends on how embedded, I guess, the system really is. If you like, yeah, if you're talking about just like raw flash memory, then I suppose there's no file system. I actually don't know anything about the systems, but like for Move, for example, it definitely has a file system, but it still uses different slots for doing the updates to do safe updates. Interested to see what happens to the header when OS updates, or maybe doesn't care. By header, what header are you talking about? You mean like the elf header or the multiboot header? Okay. So let me show you what I've gotten so far. I can, so I can build my kernel as usual, it's already built, and I can generate a grub image, which just runs these command line things. Yeah, I don't know what happens to the header when an OS updates. Yeah, I'm totally not sure. Yeah, so I can build my ISO, and I actually I have my ISO. And those PDFs on the resource page, I'd like to read them. Sure, they're not that hard to find. Oh wait, where's my browser? Grub PDF. I think really this multiboot one, that's like the, where to go? Multiboot PDF. I think this is actually a really interesting document to read. It's pretty old. This is like back from the 80s, I think. No, 90s. But Grub, which like they built Grub to implement this, and Grub is still around today, so it has a lot of lasting impact. Let me just run it. Here's what happens when I run the kernel. Actually, no, I need to run with the special chemo command. Here's the chemo command we're using now. It's very simple. Instead of this old one, which is very complicated, or at least a bit more complicated. So here's the old command. We were previously creating a disk drive or something like this with this kernel.img, and we pass it with this drive argument, and there was just a lot of stuff that I don't understand. This part stays the same now. Now we're just passing the CD-ROM. So apparently we're using a CD-ROM thing for some reason. And when I boot this, so the first thing that no longer happens, we don't see anything on the console anymore. Everything is happening via the VGA, I don't know, or the display, or whatever this thing is called. And that's like kind of annoying. I kind of don't love that. I was really enjoying this development flow where I could stay in my terminal the entire time. And I don't know, it like failed to boot the OS. Actually, we've hit the 20-second break. I'll be right back. Feel free to stand up and stretch. Was it the multiboot spec 6.96 or multiboot 2? That's a good. So in general, I'm not using multiboot 2 because this thing says it is more complicated. But that's a good question. What is the most recent version of multiboot v1 standard. We should hopefully try to use the most recent version of it. The most recent version is 6.96 from 2009. Okay, so I think that's the one we're going to use. And so, yeah, we get this. I mean, it's kind of cool that we see this, but we get this error. Entry point isn't in a segment. You need to load the kernel first. Press any key to continue. And that's kind of interesting. Yeah, one thing I'd like to just do before we do anything else is like I want to not work in this VJ console. How to make grub not use the VJ but just use the command line interface. Let's try this. All right. Okay. Yeah, I still don't see anything going on. So, wow, that completely did not help. What? Did I save this? Save the file? JOS grub config. So it would appear as if that did absolutely nothing. Which is unfortunate. Oh wait, yeah, no, sorry. What I want is for it to be serial console only via the chemo serial console. Dang. Okay. So I kind of thought that I had, I mean, I do have this thing. This is a pretty important command line for chemo. Send the serial output to your terminal. So let me try this time. Maybe that will make it work. Okay. Let's go. Let's go. We got our nice serial console only grub going. I'm gonna call that some progress. Little UART. Yeah, who needs displays anyway? I sort of have half an idea to, like, when I do my own S, not even add any display support at all and have it just be serial console only. And just not do graphics. Okay. What else can we do here? So so first off, that is a good point. I'm just going to delete this. It's a good point to make a commit. I think I'm going to make I'm going to push my dev branch. I'm going to make a grub branch. And init basic CLI grub. Wait, no, that's not what I wanted. Yeah, I want to commit this. All right, init basic CLI grub. Okay. So yeah, this is not working. Question number 2 is, how do I get more, how to use the grub shell? That's the other question. Actually, we don't even have a grub shell. Would that be useful? Let's go to the grub docs. Just because I'm curious, I'm just going to, I don't think we actually really need the shell. Okay, great. Grub is showing a TUI now. Can I make it really only use a shell interface? Oh, interesting. Print, okay. Show disables the menu I think I'm just only going to take, I actually do want it to auto boot. Well, maybe not, I don't know. Let's just try these. So the way bootloaders like normally work is they generally have this timeout concept, as far as I'm aware, where the bootloader like starts up, but it will wait a certain amount of time to like watch for key presses or stuff like this. And if it doesn't see key presses, then it will like actually initiate the boot process and like start to boot the system. So I believe that's what the timeout thing is for. I don't exactly know how that applies here, really. Like, it seems to be automatically booting things, but here, I guess we can disable the timeout is like, yeah, it's like how much time before the default OS starts, and so if we disable that, the default OS will never start. And in general, I just kind of want a bit more of a comfortable development environment. I think that didn't... Okay, this is interesting. It didn't, yeah, the timeout thing worked because it didn't even try to boot the OS, but we still have this graphical thing. But then it says press E to edit the commands before booting, or C for command line. I can do E to edit the commands, and then C, I can drop into the grub command line. And this is kind of the thing I was just kind of curious about. I don't actually know if I mean, I don't even know how to use this at all, to be honest. So I don't even know how to get out of it, actually. I don't even know what's happening right now. I can't even see anything, so I'm just gonna kill chemo? Holy crap, I'm like... Even the command to kill chemo is not working. Let me get my 1,000,000 tabs out of the way. All right. Yeah, wait. I think my only option is to kill the tmux pain. All right, kind of unfortunate. Okay, that was weird. I'm not going to do that again, I think. But for the moment, I'm satisfied. history merge. I'm satisfied with my workflow here of just booting here, having it trying to boot. Okay, my next question is how to enable more verbose logging from grub for errors. Is that possible? I feel like you can't exit them exactly. Debug all. Let's go. Debug all. Okay. Oh, check that out. Wow. Yep. It is giving me very detailed logging indeed. Okay, I don't want the script or Lexer logging. Don't want the script or Lexer logging, please. File loader, cool. Get out of here, make and run it. And then everything disappeared. So, was that bogus? File loader. Yo, what's up, John? Nice to see you, dude. Happy Sunday to you also. We're working on some boot process stuff today. Trying to get grub working. And I was ideally hoping to get some verbose output, but seems like that's not possible, or at least ChatGPT. But I don't know, it's very noisy. But maybe we can still get some useful information out of this. So it's detecting the type of file or file system that we provided, which is this like strange CD-ROM format apparently. And so something with the multiboot. It's doing some kind of multiboot processing. I don't know, allocating some memory. And then here's our error. Entry point isn't in a segment. I'm gonna take a take a screenshot of this just in case it's useful. Yeah, I was just curious in case there was anything interesting here, but I'm not really seeing anything. So let's just focus on the actual error message that it's giving us. Entry point isn't in a segment. Good question. What is the entry point? Because it's probably wrong. So let's look at the kernel and we can even just see it right here. Entry point address, this 1000C, or this, whatever this number is. It's kind of a low number. Well, okay, so this is in low memory, this is a physical address. Because normally, with the existing boot process, so we have our custom bootloader that runs and transitions into 32-bit mode, switch from real to protected. And then it jumps into the C code of the bootloader. So it's in 32-bit mode, but paging is not enabled yet. It's still in segmentation mode, but all the segments are just set to be the entire 4 GB range. And practically speaking, that just means that all the addresses, like virtual and physical, are like the same. And so now we're still running in the bootloader, and we read the elf file and we start writing it to memory based off of where it says it needs to go. And it says it needs to go here. It says it needs to go at physical address, blah, 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 which is like the 1 MB region. So that's where everything gets written to. And then the last thing we do is we jump to the entry point, which is also this physical address thing that's solidly like within the physical address range that we just wrote everything to. So that seems to work. And it seems like things are different with the grub. Like, surely, obviously, things are different with grub. There is some different expectation about how this needs to, I don't know, be linked or something like this. So, I mean, if we go back to the error, it's somewhat clear what it's trying to tell us. Entry point isn't in a segment. Entry point isn't in a segment. You need to load the kernel first. I mean, that second line, I don't really know what that means, but entry point isn't in a segment is somewhat clear because we can see that our segments are right here. Maybe I'll just copy these. Actually, no, I think I already did. My guess, I don't totally know, but I think there's some issue with maybe it's expecting that the entry point should be like a lot higher. Maybe it's expecting that this start thing should be in this like high F zone where the kernel's actually linked. Also, what's up, Afnan? Thank you for the test 1. Yeah. So that would be an idea to try. I don't know. Ideas. Can we make start a high mem kernel adder. Wow, was it already 20 minutes? All right, time for another 20-second stand-up break. Can we make start a high mem kernel address? That would be one idea. Sort of my other idea is let's just use the reference OS implementation provided by the multiboot spec. And that is, that's this thing. In this distribution, an example kernel is included. The kernel prints out some info. Yeah, so we have this, they provide this header file. I think it has a bit more than we need. This struct definition might be useful. What's up, Moose? Is this the first ever stream without the course? Yes, sort of. Quick history deep dive. So actually, streams 1 through 12 were not about the course. I was like messing with like XV6 and then I gave up. I started the course at week 13. So apart from that, like little prehistory, yes, we are in a different era. Yeah, okay. Since you missed, yeah, sorry. Yeah, it's, I don't really maintain that playlist super well, sorry. Anyway, what is actually a lot more interesting is this boot.s file. I sort of, it would be good at least to read this and learn how this is all meant to work. And finally kernel.c, which does like some stuff. Do they provide any build commands or something? Wow, this is kind of long. No. Okay. Let's just read this boot.s. Size var stack doesn't matter, flags. So start. Jump multi-boot entry. Ah, interesting. So this is where the like code actually starts running. And the way multi-boot works is that you like declare this like header somewhere in your binary. And the reason for this is because multi-boot is designed to be agnostic of executable formats. And so even if you like are using some really exotic executable format that grub or something doesn't know anything about, you can actually still use grub to boot your like weird OS by declaring some multiboot header, and grub or the bootloader, rather than parsing and loading your executable, it like scans the file looking for this magic number, and then like possibly uses some of the information in this header blob to like load the file into memory somewhere. But that's mostly if it's not an ELF file. I think if it is an ELF file, I think you have like it basically actually does know how to parse the executable and like actually properly loads it. And so in the case of ELF, which is our case, we only need the absolute minimum, which are these three fields. It's the magic, it's the flags, and it's a checksum. And I already have that. And fun fact, I already have that because they actually included it in JOS already. I want entry.s. Even though grub was never really mentioned in that coursework, you can like, if you grep for grub, it actually, they actually included like a very small amount of, like, so I added this part, but they added this thing, which I don't really understand. So anyway, there's like these weird signs that grub was like low key a little bit supported. So I didn't even need to add this. They already have declared a multi-boot header for me, which is why the boot process gets as far as it does. Well, then things immediately start to go wrong. And maybe it even just the problem begins here. What does relock do? Relock takes something and subtracts the kern base. And that's what produces this extremely low address for the start symbol. That's what's responsible for making this thing be this like 100,000 number in the first megabyte region. I would be actually kind of curious what would happen if I got rid of this. And we can pretty trivially just try this. I think actually I kind of I don't actually want to execute too much code here. I fully expect things to like crash or go like really poorly actually. And so I sort of just want to add an infinite loop. I'm just gonna do jump spin. We already have this spin symbol, right? Just jump spin. So I think this should hopefully, like, if everything works, which would be great, we made this change, which now maybe would make grub actually be able to handle the binary, although I'm not sure. And then let's say it did work, it would actually redirect execution to here, at which point we wouldn't see anything because it would be stuck in an infinite loop. But maybe we could actually use the debugger and just like observe that we hit this like spin. Do I understand what that start does in ASM? I mostly understand this. Yeah, like if you're asking about this assembly stuff that happens here, I have a pretty good understanding of it. And then start is just like the start symbol, like it's just the most basic entry point into a binary usually, as far as I'm aware. Yeah, all right. So let's try it. Okay, let's try it. So what we need to actually need to rebuild the kernel, then rebuild the grub image. And actually, while I'm here, I'm just going to rerun readelf and see what we can observe. So now check this out. So now this thing is way different. Entry point address is it's just the same but like way higher. So now it corresponds really to like that that high memory address. But actually, I don't think this is going to work. Something still feels like kind of wrong. This high memory address only really becomes a thing once we enable paging. And paging happens kind of late. Paging gets enabled right here. And so grub does not enable paging as far as I know. Or at the very least, if it does, it disables it before it gives control to us. So I actually just don't expect this to work, but I'm curious what happens anyway. Okay, so we make the grub image, and then now we run the chemo command. And we enter this, and then what happens? That was extremely noisy, and now I need to scroll back a million. All right, I think I'm going to disable all this logging. It makes it impossible to actually see. I'm going to disable that. It makes it literally impossible to see. What's going on? Make grub image. One more time. So this is kind of interesting. Indeed, like nothing is really happening. What about now? Oh shit, okay. So I was just trying to use GDB for this actually, but I think now, I guess it's probably time to actually change the make file. So here's what we're gonna do. So now we basically just swapped out CD-ROM. And I think I'm going to just disable all of this stuff. That's all for stuff we don't need at the moment. Address already in use. What's going on? Okay. I've never seen this error before. Failed to find. Cannot start GDB server. Oh wait, no, I'm stupid. Wait a sec. On one side I run chemo, make chemo GDB. On the other side I run make GDB. Continue. All right, so now things are running, and I'm in grub. And I'm going to press enter. And we don't see anything, so maybe things are actually working. Now I'm going to press Control C. I don't know. We're at 1040, which is kind of an interesting address. I don't know. Let's check out what is there. Do we... Oh wait, no, this is the wrong file. I need a kern entry, kern.asm. Yeah, okay, wait, check this out. Check this out. I think it kind of worked. So here's spin. And when I broke in the debugger, we ended up at instruction 1040, and that's actually the spin instruction. That is very interesting. I don't really understand actually why this is working, because as I explained later, paging hasn't been enabled yet. So I don't really understand what grub is doing with our entry point address, our like very high entry point address. But somehow I think it is kind of working. This is very interesting. Okay. Let's, so what do we do from here? I'm going to quit. Wait a second. There are like some, chemo has a couple of like interesting features for OS developers. Like one of them is a super easy serial console, like serial console output via an IO port, I think. I don't know. I could technically try to print something out, but I think actually I'm feeling confident or maybe lucky enough to keep going. So I think it actually did get here. I just don't actually know what would happen if the kernel were to crash in this state with grub and stuff. Like maybe it would reboot the machine. What I'm going to do, I'm going to add a panic. All right, time to, I don't know, cons init. Panic 222. This would be wild if it worked. I don't expect it to work, but I'm going to make grub image. And then we're going to run make chemo GDB and then make GDB. We're going to continue and we're going to click yes. Holy shoot. Yo, that worked. Check that out. That was a lot easier than I thought it would be. The kernel's running. We hit the panic. Okay, that is interesting. Yeah, where's my soundboard? That's very interesting. I have a lot of questions as to why that works. But I think it worked. So let's just not panic and let's just what is the minimal code to get a shell going? I sort of forget. All this file system stuff was kind of annoying. I might need to re-enable some of this stuff. So I'm going to re-enable this. I think that's it. I think I can just re-enable these things. And but something happened. Okay, that was, yeah, something weird happened. Okay. So I'm going to make grub image. Oh, is it already another time for a 20-second break? Okay. Be right back. Feel free to stand up and stretch. Okay. Let's just run it. Look at that. It's working. Yeah. Huh. That is fascinating. That was a lot easier than I thought it would be. I thought we would have to adjust some, I don't know, some stack stuff or stack pointer or something, or physical memory paging, I don't know, something like that, but it seemed to just work. And all we needed to do is basically just change this. That was the one thing we need. Yeah, that's kind of cool. Set timeout -1. Just curious. Okay, so I think it seems like this thing doesn't do anything. I'm kind of curious if I can use that like key press thing to enter the boot menu, given the timeout. So if I run make chemo and then don't do anything, it just like booted the OS and just like did stuff. So, and if I do this, but then smash my keyboard, will it, okay, that did not do anything. If I set the timeout to 5 or something, what happens now? Grub image. So now it's gonna wait, or it waits here for 5 seconds before it boots. I see, interesting. Cool. Grub can boot anything. Legacy is so huge. Yeah. Okay, well, I don't know. That's cool. There's a lot of different things we could do now. I'm just going to screenshot this. This was the only thing needed to make grub work. Why? Isn't it weird that grub can do something with such a high kernel virtual address before paging is enabled? Seems weird to me. One other thing we can do is check out this multiboot info struct we get passed. Another cool thing that might be interesting is working on some kernel command line arguments. That could be cool. That's kind of part of this, I believe that's kind of part of this multiboot stuff, is that at least in the maybe command line. Multiboot. Okay, this is the multiboot command for grub, which is what we're using. All I do in my grub config is say multiboot /boot /kernel. And it does something with it. Load. The rest of the line is passed verbatim as the kernel command line. Yeah, and then, so how is that passed? That's like kind of an interesting question. If I search for command line here, maybe with a space. Yeah, that's kind of cool. So bit 2, if bit 2 is set, the command line field is valid and contains the physical address of the command line to be passed to the kernel. And like what section are we in? So we are looking at boot information format. Also, quick side note, but this machine state thing is super interesting. I mean, a lot of it's very interesting, but this describes exactly the register state and like a lot of details of what happens when you get control from the bootloader. And it tells you like EAX has something. So EBX contains a pointer to a multi-boot information structure. And currently, we are just completely throwing that away. If we look at our entry asm, I mean, I don't know if we have any explicit uses of EBX. I don't think we do. But basically, it just gets immediately trashed as soon as we call into the C code, which starts using EBX. So one thing that could be super legit would be to like not trash that register and instead like pass it to this C function. That sounds kind of fun to try, actually. So if we go to we need to go to I'm going to clear out some of these files we don't need. GNU make file input and C. So if we go here, currently this function is a void function. let's say we changed it to take a, I mean, it would be a pointer to a multi-boot structure. Maybe it is time to start copy and pasting some like this header from the internet. So here's how here's how they do it. They pass a magic and an adder, and they like cast the adder to a multiboot info t. So I'm feeling a little bit lucky, and I'm just gonna copy and paste this header into my operating system somewhere. Where should we put this? What's the structure here even? Inc. So we're just gonna need this within the kernel, so I'm just gonna make a new file. multiboot.h. Sick. We got multi-boot header. And hopefully that should be available for inclusion now. Right? Okay, that seems to compile. And then multiboot info t, multiboot p, multiboot info. How about that? Const, I don't know. And then we go to entry.s, and what do we do? Where is it? I don't know, we need to push EBX? Because EBX contains the pointer. It's this physical pointer. In fact, maybe it would be nice to name it that way, but we're just trying to pass an argument here. So let's try that. I suspect if we look at the reference kernel, it would do something very similar. So we're going to make this, and then we need to, we wouldn't really see anything unless we do something. I'm still maybe just going to like panic. What is something? I mean, let's just try to get a command line argument. Let's try to get a command line argument. So, let's say we wanted to implement kernel command line arguments. So here's how we do this. So the first thing we need to do as a kernel is we need to kind of like advertise to the bootloader that yes, like we want like command line arguments, please. I think by default, basically all the features are like off, I think, and then you can selectively enable what information you want the bootloader to pass you. And I think you do that in these flags. Yeah, so you pass some flags. Or maybe not. We were kind of looking at this earlier. But you can get a lot of cool stuff here. You can get the amount of upper and lower memory. That's kind of nice. You can get some other stuff. But we are interested in this thing. Did I copy and paste that already? No. All right. If bit2 the command line field is valid. So what is, right, and what is this flags thing again? I'm pretty sure it's the flags that we put in the multiboot header, right? Command line here is this pointer. If flags 2. There's no other flags that we're talking about other than this thing, right? But then it's saying if bit2 information about the video mode table must be available to the kernel. I'm kind of confused. I'm just going to copy this. I'm going to copy this thing, which is confusing me. Okay, is there an easier field that we can get? You know what? All I'm going to do, I'm just going to, let's see, boot info. I'm just going to print the pointer and just see what it is. And then we'll just panic. Let's just try this. So we have a pointer, hex 10,000. That's kind of an interesting pointer. But it's a good first step. So I think we, I mean, it wasn't that hard. We just needed to push ebx before calling into this function, and then now we can receive a pointer as the argument. I think we're so close to getting a command line. If bit2 is set information about, see section 3.3. Required. Let's print out these flags. So we have a legit header, like a legit official header. So let's flags. I don't remember how to print out a flags. I don't know. How do I print out a hex number again? It's just, dude, I always forget if it's like X or XU or something weird like that. It's pretty cool. Flags 1A67. That's kind of interesting. Seems like a lot of flags are there. Oh, maybe, wait a sec, maybe I understood this wrong. Okay, previously I said that the way it works is that you, as the OS, need to advertise what information you want, and then the bootloader will pass it. And I think that's partially true, but I was confusing two different things. So that is partially true. You can do this. For example, you can set bit 2 and get like some video information or something like this. But that's actually not related to what we're interested in here, I think. I think for this stuff, the flags is just a way for the OS to check like if it's safe to access things here. But I think at least for the command line, I believe that that is just by default, like grub is going to pass this to us. And the flags is just so we can do like a check basically. So let's, it's just going to be something like if p multiboot info flags and 2, no, 1, it's bit, no, it's bit 2, right? It's gonna be 4. Then I'm just gonna panic, got flags. No flags. So if, or I don't know, 1, 2, if that is set, then we can take a 20-second break, be right back. All right, this is gonna be good. So if then we can safely get a pointer to fizz args, I don't know, equals p multiboot info command line. And then to do anything with that, we need to convert it to a kernel virtual address. And then we can, big moment, but we would be able to print it out. Of course, it's not fizz anymore. It's just args. Let's just call it args. Well, let's call it command line. Anything else we need to know? And then I think the only thing else we should do is just pass like a command line arg. Like arg1. I don't know. Because I believe that's what it said. Right, it says the rest of the line is passed verbatim as a kernel command line. Let's give this a shot. Build, generate the image, bam, boot the OS. Kadder called with invalid PA. Oh, wait. Interesting. We were not able to convert this to a kernel virtual. Oh, wait, but maybe I'm doing this way too early. Maybe we should at least initialize memory first. I don't know, actually. No, I think that shouldn't actually matter. What's the problem if page num PA n pages? Okay, n pages isn't set yet, so I think, yeah, we're not able to do this until we initialize memory. I thought we would be able to, but maybe not. That's kind of a funny panic, actually. This panic, the goal of this panic is to prevent us from trying to translate a physical address that is actually greater than the region of physical memory. Something like this. But actually it fails right now because it's just set to 0 until meminit gets called, I think. Let's try this one more time. What's up? Also, what's up? Unidul Islam Yarif. Where's the source code link? I'm not publishing the source code for what I'm doing at the moment. So there's no GitHub or anything like this. You can find, but what is available is my archive of JOS, which is basically the same thing as what I'm showing, except it's not finished. And I'm working with the OS which I've finished. Okay, so we build this and then we do what? We run it. Oh. So this is what it looks like when the OS crashes now. It reboots the machine. So our first grub crash. Okay, so it does do this. Oh, wait, that's why. Yeah, no, this p, because this thing is a physical address. So what we need to do is right off the bat, multiboot info t. Oh shit, but we need to be able to do the translation first, so we're gonna do this. Kadder of pfizz multiboot info, and then no. Yeah, so we just, and then now we can safely access it. Okay, because it passes us a physical address. So now let's try that. Oh, what's the problem? Oh, I see. I need to cast this to fizz add. You know what? Actually, yeah, this should just be declared as fizz adder t. Actually, okay. Make grub image, and then make chemo. Okay, no, the panic is still there, unfortunately. Oh, what? So that, what? Invalid P89797. What the fuck is that? Am I... What is this thing? Wait, okay, P multiboot info. Am I doing this check right? Flags and the second bit, right? The command line field is valid. If bit 2, the flag's long word. Like, this is not that complicated. This really should not be that complicated. In fact, I mean, we should just be able to... We could also just do this in the debugger. I sort of feel like that might be good to do at this point. bi3a6 init. Okay. Next. Does this work? So P, so I'll just dump. Yeah, something's not right. Wait, what? Something's super wrong. Why are all these 9 7s in memory? But also, didn't I previously print something else? So earlier, actually earlier I did something kind of weird. Here I think I directly printed flags, but it was something like this. Oh, but maybe it printed, wait, no. What happens if I do this? Here's where 1A67 But actually that doesn't, I don't even know what that is. That doesn't quite seem right, because wouldn't that mean the command line field is not active? Because, oh wait, no, yeah, wait. Oh, 7 means, yeah, so 7 means the bottom 3 bits are active, so that's fine. So I feel like that was actually working. So what happened here? Triple checking. This thing says so EBX contains 32-bit physical address of this information structure. And then if bit 2 is set, the command line field is valid. Yeah, I think it might just be time to just fully just do all this in the debugger. Chemo GDB. So 6 init, continue, run. Okay. Ah, wait a sec. Actually, it is, at this point in the code, we actually still, so, wait, no. So at the, maybe. Wait, at this point in the code, we're still running with the entry level page tables, which map, in which the first 4 megabytes are actually mapped. And that's why it's safe to just access this physical address. Yeah, I do need to actually leave kind of soon, but okay, here's what I'm gonna do. I think actually this should just work straight up. It's actually safe. Okay. Multiboot info t. It's, for the moment, it's actually safe in this point of the code to actually access super low memory addresses because they are still mapped, and therefore it's safe to access the flags. We don't even need to do this conversion, and I think this should actually just work. And so that's my final Hail Mary. I'm just gonna comment all this out. This needs a cast. Okay. We're launching a Hail Mary. Yo, there, we got it. We got it. All right, soundboard's coming out. We got our ARG successfully landed. Oh no, wait, gotta connect it. Ugh. Air horn, some claps. Yep. So check it out. We have a command line. We have kernel command lines now. It's kind of sick. Yeah. So here's what that means. That means I can boot the OS and edit the command. And then like on a particular boot, I can be like, disable feature. And then I can press Control X to boot. Boot. Dang. Press, or F10. And check it out. Command line arg. That's sick. Yeah, that's gonna be worthy of some horns. I'm pretty satisfied with that. So that's just another step along the way to having a bit more of a professional kernel, the ability to get some command line arguments in there. Nice. All right, I think that's gonna be it for me today. Sub 45, now how to learn to do this stuff. So I will just link you to my resources page. I recommend pwn.college to people, and I'm also recommending this course to people, the one that I've been doing for about a year, which is how I learned to do a lot of this stuff. But yeah, man, that's cool. I'm very satisfied with that. We got a command line. We can pass a command line into our kernel just like you can do with normal functions, or normal programs. All right, well, that's gonna be it for me today. I'm just gonna paste my Discord link. Thanks very much for watching. Please subscribe to my channel if you like what I'm doing. Next week is going to be a pre-recorded stream, but I'll be back the week after. And until then, nice seeing you. Nice seeing you, John. Or thanks for hanging out. Yeah, peace. Later.